Okay, class doctor can be defined with the def init body. This one, self, name, speciality. Okay, and self name is equals to the name, and self speciality is equals to the what, to this one. Okay, and also def disp self print f self name and self speciality. Okay, but this doctor contained in the what, in the hospital. Okay, class hospital, def init self doctors can be built with the what, with the list. Okay, and so we can store the every doctors within this hospital can be appended or was stored in this body. And so the def add doctors self and doctor can be given in here, just like this one, and self doctors and append doctor can be added just like this one. Okay, and def disp self for doctor in self doctors is contained in here and so doctor disp can be called in here. Okay, so the hospital built with the hospital. Okay, and after that the doctor one doctor can be built with the, for example, the Yara Ali, and this is the surgery. Okay, and doctor 2 is the what, Dr. Halil Güneyme. Okay, and so this is the nurse, not a nurse, it's the orthopedist. Okay, so hospital can be add with the add doctor doctor 1, and also doctor 2 can be given in here, and hospital disp can be called in here. This is the simple aggregation example to what, to possess these properties. Okay, and so this 2 doctor contained in the what, in this append function or the list of the doctors. Okay, this is called the aggregation. Do you understand that? Do you have any question? This doctors is given in the what, in this hospital. Okay, and so we will continue with the class of vector. In Python, in C++ programming language, we have a default vector class to iterate or create the linked list, but in the Python we don't have kind of this property. But how we can write this vector class in the Python? Okay, this is now the init function should be given in here. Okay, and so the self and elements should be given in here, the self elements with initialize with the elements. Okay, and after that we have a special operators in the what, in the class. For example, def add self and other can be given in here. What's the purpose of this add operator? Add operator, just like the operator overloading mechanism in C++ programming language, which means that we can add or plus or the subtract any other function or the variables which is defined with the type of the vector in here. Okay, So this add possessed with the what? With the vector class. And so double underscore means that this property is only current for the what? For the vector class. Okay? And so if len self elements not equals to the what? The len of the other elements. Okay? Which means that if we have the vector, for example, 1 and 2, the vector possessed what? The yi plus 2j. This is a different direction in the what? The vector notation in the math. Okay? And so we need to check firstly the elements of the self and the other elements are equal to each other. Okay? And so we need to throw the value error in here. Vectors must have the same length for addition. Okay? So if this is the case, and then the result elements can be built with what? With the least values a plus b, but for a, b in zip. Just remember the previous lesson. The self elements can be searched and the other elements can be searched by using these notations. Okay? And also we need to create the new values of these terms. Vector is built with the results of the elements. Okay? So how we can write these properties? This is the add function. Okay? And so we can create instances of the vector class. For example, the vector 1 vector with the initialized element of the 1, 2 and 3. Okay? And also vector 2 can be at 4, 5 and 6. Okay? So how we can check these values? So normally we need to plus the summation can be done with what? The 1 plus 4, 2 plus 5, 3 plus 6, right? But in the operator overloading mechanism, the result of the addition in here can be built with what? The vector 1 plus vector 2. Okay? If this is the case, and so if I rerun this code, and then we will now have error in here. But why? First of all, we need to terminate this function body in here. Okay? And so if I run this code, and then the vector 1 plus vector 2 unsupported operand types for plus, vector and vector, which means that the default plus operator cannot be used in this case. But in the class, we have a function underscore underscore add underscore underscore in here. If we write this code, and then we can apply the basic elements of the math arithmetic, just like the plus operator in here. Okay? So if you want to print this value, vector 1 plus vector 2, just like this one, the result addition can be built with these terms. But if I run this code, the vector plus vector 2 is contained in the what? The main vector class object at the what? The some specific address. How we can specialize this str value with the utilization of the operator overloading mechanisms? Just here that we have one more another function underscore underscore str, which means that if we want to write or print the specific purpose elements, just like this one, the return f vector. See, this is the open and close and self elements can be built in here. And so if I rerun this code, this result addition automatically called to this str values in here, which means that if I rerun this code, and then vector 1 and vector 2 is seen on the page of the what? The vector 5, 7, 9. See, we can specialize the our operators plus, negative, or multiplication, or the written function based on the what? The class elements, just like this one. Do you understand that, guys? This is the operator overloading mechanism in the Python programming language for a given specific class. Do you have any question about that? Do you understand that? How we can use this property? For example, if we have these properties just like this one, if I choose the what? The negative values. Other elements means that. Just see that. This result addition operator are using in here, but normally the Python sees that code just like this one. Result addition vector 1 dot, just see that, add vector 2. Okay, these two codes are identical with the next one. Actually, this plus operator converted by the Python interpreter into this code. Okay, this add function automatically called by using the plus operator in here. Do you understand that, Yara? If we are using this syntax, and so the result 5, 7 and 9, these are two identical. Vector 1 sees the plus, and which means that the vector 1 calls to the what? The add operator overloading with the passing into the what? Other elements to the what? To the vector 2, right? Do you understand right now? These are identical. Okay. How about this one? Minus operator. If you write this code and then see that the result addition vector 1 and 2 unsupported type is given in here, and so we need to create the add one more another function in here, just like this one. See that def underscore underscore, and so we have more underscore operator in here, just like this one. See dir ek init new or reduce, or in here we have one more properties, just like it's called the sub. Okay, and sub self and others should be given in here, and so this sub is used to what? To subtract the two vector elements in here. And always we do if len self elements is not equals to the what? The len of the other elements, and raise we need to give the value error in here. Vectors must have the same length for subtraction. Okay. So if this is not the case, and so the elements results elements a minus b for a b in zip self elements and the other elements should be given here. Okay, and after that we need to build the what? The vector with the initialization values of the what? The result elements. And if this is the case, and so if I rerun this code and then minus 3 and minus 3 is seen in here, because the 1 2 3 4 5 6, this is the 1 4 1 minus 4 minus 3 2 minus 5 minus 3 3 minus 6 minus 3 in here. But what is the identical code with this one? Just see that the vector 1 sub function are identical with the what? With the previous one. Okay, see, Do you get it? Okay. And so with the same idea, def mul is the multiplication operator overloading mechanism. But in this case, we use the scalar elements result elements is called with what? With the a times scalar values for a in self elements. This is the comprehension, guys, right? And we need to return to the what? The vector result elements. Okay? And so we can define to the what? The scalar, for example, 2. Okay? And so the result multiplication is built with what? The vector 1, for example, times scalar. Okay? And after that, we can print these values just like this one. Vector 1 times scalar value is equals to what? The result multiplication. See, 2, 4, and 6 are given in here. Or we can write this result multiplicator with the what? Dot mul scalar. Okay? Do you understand that? Okay. So, how we can build the complex another example in here? This is called the operator overloading mechanism, guys. And so, how we can specialize this operator overloading mechanism? First of all, we can build the class advanced math operations. And so, first of all, class variable to keep track of the number of instances. We should define the instance count variable, but this possessed with what? Class attributes. Okay? And so def init can be written just like this one. Self and value can be given here, and also self value should be assigned with the value. But at each case, advanced math operation instance count is increased with the 1, because we know that this is the R constructor. Okay? If we create any object related to the advanced math operation, and so this must be increased with the 1, because we want to count it in here. And so also we know that this init function must always be called in the what? In the creation of the new instance related to the advanced math operations. Okay? And after that, def add can be built with the self and other values, and so the result is equals to what? Self value plus other value. See? And so return advanced math operation with what? With the results. Okay? These are the basic constructor values on here. So we can add another function, the mul, in here. And so in the mul we should multiply these values. Okay? And also we just write the def str for printing these operations, the return str values, the self value, right? In the printf, we can use these properties. Okay? First of all, we need to create the instances. For example, instance 1, advanced math operation with the initial values of the 5. And so, in the second place, with the initial values of 3. Okay, and so if I rerun this code, then we have no error. But just see that the print advanced math operation constructor is called. Okay, or we can write these values just like this one, and constructor is called number of instance, can be assigned with the what, with this one. Okay, so if I run this code, advanced math operation constructor is called number of instance 1. The other one, advanced math operation constructor, is called number of instance is 2, because it's the global or class variable or the instance counter. Okay, and after that, if we call the result addition, is in here instance 1 plus instance 2. See that these two class can be collected or summed with the what, with the this function. And so what is the output of this code right now, guys? What is the output of this code? Can anyone tell me? Just see that this function calls to what, the add operator, and so adds to the value and the other values. Okay, and after that the advanced math operation is created. And so if I run this code, see, advanced math operation constant is called, and the number of instance is the 3, because the result addition is newly created in here. Okay, and also result additions, the multiplication can also be defined mul. This is the add. Okay, and so mul, and if I run this code, and then we will have the 4 number of instances in here, because result mul and result add is created with the what, with this addition operator and the multiplication operator in here. Okay, do you understand how we can handle these properties in here? If there's any question, please ask me. Okay, and so in here printing str. What about this one, the print instance 1, instance 1? What is the output of this code? Just tell me. I'm waiting. Arkadaşlar anlıyor musunuz dersi? Hiç kimseden ses yok. Yara. Printing str, but the another values must also be given in here. Just see that the instance 1 printing str is given in here, but and at the end of this code the 5 also is given in here. Okay. And also instance 2 see, is the 3, right? Or result mul result add and result add can be given in here. So the printing str is a default argument for the what, for the str operator overloading mechanisms. Okay. Please ask me anything about that. This is so important. This is operator overload mechanism in the Python programming language for a given class. Okay. If there's no question, and so I will ask this topic in your project. Okay. So right now we need to add one more another function. Write to file. Okay. Self and file name given here with open is a specific function. The file name, we can create a text file as a file. Okay. And so the file write str and self value is the string conversion, and we can write the anything based on these informations. Okay. And also we can build what the result mul. Okay. Can we write the file to the what, to math operations txt. We can write the anything by using these conversions. Okay. Also add can be given in here, just like this one. Just see, math operation contains the what, 15 and the 8. What is the values of the 15? 15 result add is given with what, the 5 plus 3, but the other term 5 times 3. And also we can write the whole operations on the what, on the math operation txt file. Okay. See. And so we can contain the every variable in here, but important thing is that the result mul possesses these values. This is the advanced math operation class elements, which means that normally we can sum two values in the integer one, but we cannot write this file to the math operations, just like this one. And so if we specialize our class based on these features, and then we can write our own mathematical theorems or the print function or the another things, just like this one. For example, in your operation maybe other values times with a 10 and mul times with a 10. What is the output of this code right now? If I rerun this code, we have the result mul as what, the 150 and result at the 35. This is a specialization of the what of our class or the advanced math operation in the Python programming language. Okay. Any question? Guys. Yes, Yara. With as is a special keyword in the Python. If we want to build a txt or another file in here, we should use the with open, with an s function in here, because the with as is a protective detail for our file operation, because the file operation is the outside of the R code. And so if we create this file and terminate this file, we should utilize the with as keyword. Otherwise, the R allocated region cannot be fed into the what? Into the RAM location. This is a protective detail about what the opening and closing to the file operation in Python programming language. We will talk about it. Okay? Okay. So, in the last case for today, we will create another examples. 11, and also we should get this class advanced math operator in here, just like this one. Okay, so this should be removed, and also this should be removed. Okay, and so in this case we create the advanced math operation class in here, but this is the random generator examples. Okay, so in this case we create a class to generate random samples. Okay, and so in order to do that, just remember that the random is a specific library, and import to the what the pandas as pd in order to what, in order to write the every data into the dataset structure, which is called, or which is defined in the pandas library. Okay, and also we need to import the matplotlib library. With the pyplot utilization as plt, we can draw everything by using the plt function in here, because the pyplot is a specific class to the what, to the GUI manager for drawing the every data in this case. But I need to use the advanced math operation for these tasks. Okay, so how we can do that? First of all, we need to delete these bodies. Okay, and also delete this one, and also delete this one, and also delete this one. Okay, this is our basic proper features for the advanced math operation classes. Okay, and so we can add and move any number based on these informations. And so we shall define to the what, to the some specific point. For example, def generate random dataset. Okay, and we can give the size properties in here. This is a global function, and so dataset can be built with the initial values of the list element. This is an empty list, and so for underscore in range of size. This underscore means that we don't need to use this property, just we should create the what, create the loop until to the what, until to the size. For example, 0 to 1000, 0 to 10,000. Okay, and so value is generated with the random library uniform function, which means that 0 to 10 is given in here. Okay, and so we can generate what, the random values between the 0 to 10. After that, we can add the dataset by using the advanced, but in this case advanced math operation should be initialized with the values. Okay, see, and so we should return to dataset, and so this dataset contains the what, the advanced math operation class instances, but with the initialized values of what, with the values. Okay, this is simple. So how we can write these values into the Excel file? Write dataset to Excel. This is the R function. And so dataset should be given in here, and also file name should be given here. So data can be built with the what? With this value and item. Value for item in dataset, right? So this dataset contains the what? The size of elements of the what? A random value, okay? At each value, item value should be assigned with the what? With the values in the dataset, okay? And so just see that this is the what? The dictionary values of these terms, and so the value of this term is the key, okay? And so this key is related with the what? With the some specific values of the dataset, which is generated by the random values, okay? And so this df can be used within here with what? PD data frame function and passing to data, and df to Excel can be built with the what? With the file name, and the index should be equalized with the false, okay? This is the written operation for this case. And so how we can test this algorithm? Test algorithm. So dataset 1 generate random dataset 10, and also 2 can be created in here, just like this one, okay? And so how we can write these values? You see the write dataset to Excel. So dataset 1 and dataset 1.xlsx, okay? And also we can write the dataset 2 and dataset 2, okay? See? And so if I run this code, and then this dataset are written in the what? In the Excel files, right? And so if I open, I'm sorry, we're in File Explorer. Dataset 1 is equalized to values as a key value. Just see that we have the 10 number in here, but in the random order, right? And also dataset 2 is given in the what? In this case. See, this is the dataset 2, this is the dataset 1, and we can easily write the whole the values to the what? To the Excel file by using these terms, okay? Don't save. And so this is the what? Our implementation. But how we can add or multiply these values based on these informations? Just see that. Result addition can be built with the what? Item 1 plus item 2 for item 1, item 2 in zip dataset 1 and dataset 2. See, this is the advantage of the utilization of the advanced math operation class, because each of the elements are created in the form of advanced math operation instances, right? And so we can easily generate the random dataset, but we cannot sum these two values until to the what? Until to this add function is given in here, okay? See that if I run this code, rerun this code, and then we will not have error. But if I remove this add function in here, just like this one, if I rerun this code, and then item 1 and item 1 cannot be created in here, because the plus operator cannot be built in the what? Advanced math operation. See? And so we can add the two class elements using the what? The add function easily. And also we can pass these values into the another place with the specialized form. Okay. Also, we can multiply these values just like this one. Multiplication. Okay. And so we can multiply it, but until to the what if we have the mul function in here. Okay. So we can write the dataset to Excel. Result addition can be given in here, x ls x, right? And also result multiplication can be built with these nominations. See, if we have these properties, this is not the result addition is given by with the what? With the summation of the random element 1 and random element 2. Just see that this is higher than 0 to 10 values, which means that this is the summation of the two elements in here. This is the summation of the two elements in here. This is the summation of the other elements. Okay. And also result multiplication is given in here, 44, 73, 29. Okay. So we can easily write these values in here, just like this one. Okay. So this are the case. Okay. We can also build with the what? With the read dataset. Def read dataset from Excel. Okay. File name should be given also in here. And so df pd has a special function, the read Excel values in here for the file name. Okay. And dataset can be built with what? With the advanced math operation values for value in df keyword of value, right? This is the R basic operation to create the R dataset. Okay. Because this dataset is read from the what? The df possess the whole values of the Excel file, and so Excel file can be reachable by using the dictionary values with the keyword of the value, and so for each value is assigned with what? With this term, and so we can return the whole values just like this one. Okay. So how we can read these functions? Just see that it's the read is assigned with what? The read dataset from Excel, and so this one should be given here, and result multiplication, and this is the result multiplication. We can read it. Just see that if I rerun this code, and then these two result addition and result multiplication are created in the what? In the Explorer. Okay. But how we can draw these values? We can add one more function, def visualize dataset 1 and dataset 2. Okay. And values 1 can be built with the item value for item in dataset 1. This is the comprehensions. Value 2 is assigned with the 2. Okay. And so we have a special PLT function in here, it's the ORD class. This PLT is a class to what? To draw any dataset on the GUI. Okay. And so this PLT figure can be built with the what? The fixed size of the what? The 10 and 6. Okay. And PLT plot can be built with what? The values of 1, and label can be assigned is the default argument dataset 1, and marker is assigned with the O, and also values 2 and dataset 2 and marker can be assigned with the X. Okay. And PLT title can be assigned the dataset visualization. Okay. And PLT X label is equals to what? To that data point. Okay. And PLT Y label is the what is the value. Okay. mplt legend must be opened, mplt show must be called. Okay. So how we can visualize these terms? Visualize dataset. The read values can be given in here based on these informations. And so if I rerun this code and then see dataset 1, or this is not the dataset, this is the first one, result addition, this is the addition, this is the mul value. Okay, this label can be reassigned just like this one. See, add and mul are given in here. Just see that it's around the 10, this is around the 73. But if I rerun this code, we have the different graph because it's a random values, guys. Okay, these are random values. Just see, if I rerun this code and then see that it's a random values. Okay, so any question? See, we specialize the math operation by using the advanced math operation class, which our own class written by us. And so we can easily set the generate random data set, and we can write the whole data set to Excel, read and visualize whole data set by using these libraries. Okay. But just remember that if you want to do that, the item 1 and item 2 must be defined in the in the advanced math operation, because it's a specialized advanced math operation. For example, if I choose the plus operator in here, and so we can print the plus operation can be given in here just like this one, or the mul is given in here, and so the many times these functions are called. See, mul plus, right? Because we have the 10 values in here. For example, if I choose the 2 values in here, and so see, plus mul is given in here, right? Because at each case this operator overloading is written in here, right? You can test our algorithms to learn about how we can handle these values of these terms. Okay, any question? If there's no question, and then we have ended up here, because in the next lesson we will continue with the inheritance values. Okay, and so today is enough for our class implementation. Please solve every example that I'm building in this class after the class. Okay, so there's no question, and so we can end this lesson.